Hi, this is Patrick from LSAT Lab. We're here to talk about must-be-false questions in the logical reasoning section. These guys are pretty rare, only about 1% of questions, so on most tests we don't see any of these. And when we do see them, typically it would only be one per test. We want to talk about how to spot one, how we should think about reading it and breaking it down, what sort of reasoning structures are likely or unlikely to show up, and what sort of trap answers we might look out for. Here are a few examples of a must-be-false question stem. Which of the following must be false? Keywords. Too obvious. Which cannot be true. If the statements above are true, that tells you you're doing some sort of inference question because they're calling the paragraph statements rather than an argument or reasoning. And instead of asking us what must be true or what's most supported, as a typical inference question would, this actually says which can't be true. This one feels a little bit more like logic games, where we are often asked each of the following could be true except, and we know to convert that into 4 of them could be true, 1 of them must be false. There's a softer version of this that's sort of like the difference between must be true and most supported. Instead of flat out saying must be false, they'll just say it's the least compatible. But when LSAT uses the term incompatible or incoherent, it means contradictory. So the least compatible means the most contradictory. Again, this question stem is referring to the paragraph as statements, which tells us we'll be reading facts and information, not an argument. When we're in the inference family, we're not reading arguments, so we're really reading facts and seeing if they have any relation to each other. Particularly, we look out for conditional and causal relationships. We look for overlapping ideas. If something's being brought up more than once, then usually we can derive something by combining the 2 facts we're given about a certain thing. If we are reading and we see conditional logic wording, we'll definitely start thinking about maybe diagramming some of the conditional logic. If we see comparative or causal wording, which is much less rare here, then we might enter more of that sort of mindset, seeing if there's a causal chain or trying to sort of itemize where are there similarities, where are there differences between these things being compared. When it comes to step 3, anticipating an answer, there are 2 main directions that you will usually see a correct answer go on a must be false. It'll typically either contradict a conditional statement that we were given, or it'll contradict a possible inference that we could have made. Let's look at each of those. So let's say that Solomon is a polite eater. He only double dips his shrimp when the cocktail sauce is down to its last bits, and he often uses a wet nap after he's done. If we were being asked, which of these must be false? Could it be true that using a wet nap is considered impolite? It's kind of tempting. I mean, we said Solomon was polite. We said Solomon uses a wet nap. So this feels like it's going against that. It's saying using a wet nap impolite. However, it never connected politeness to using a wet nap. Both of those things were mentioned, but it never said, if you're a polite eater, you always use a wet napkin after you're done eating something messy. So this does not contradict anything. B says that he always uses a wet nap before he eats. And we might think, well, we don't know that. We only heard that he uses it after he's done eating. Okay, this is wrong. But is it contradicting anything? The danger on must be false is that we confuse something that we wouldn't be able to prove with something that is provably false. So we don't have any idea. Maybe he uses a wet nap before he eats and after he eats and throughout. He goes through a lot of wet naps when he sits down to eat shrimp. All of that is compatible with the passage. C says that at his birthday party, he took a fresh bowl of cocktail sauce out of the fridge and dipped his shrimp in it twice. It seems like a relatively innocuous idea, but wait, we were given a rule that says he only double dips if it's down to the final bits, and this is a fresh bowl. So this actually does contradict something we were told. We were told a conditional, signified by the word only when. Only and only if and only when always indicate necessary conditions. So this is actually telling us that in order for him to double dip his shrimp, it's a requirement that the cocktail sauce is down to its last bits. Required things go on the right. That's called the necessary condition. The necessary thing. The contrapositive would say, if the sauce isn't down to its last bits, he's not going to double dip his shrimp. But we were just given a counterexample. When you're trying to contradict a conditional, it has nothing to do with negating or contraposing. It just means provide one counterexample. The form of a counterexample is always something in which the trigger happens, but the outcome doesn't. So in this case, he double dips, but it was not the case that the sauce was nearly done. So C would be the correct answer here. It contradicts a conditional. One of the ways in which they make that answer less obvious and less appealing is by putting in extra details like birthday party or his fridge. If we see a conditional in the statements, we should pay a lot of attention to it because it's very likely that a correct answer will do this, say that the trigger happens, but say that the outcome isn't happening. The other type of correct answer on a must-be-false question is an answer that contradicts something that we could have inferred from the statements by pulling two or more facts together. If we look at these statements, Solomon has been trying to cut down on his shrimp eating. For the past 2 weeks, the number of shrimp he's been eating has indeed declined, although the total weight of shrimp he's eating has not. And every day he writes another blog article about freeing himself from the tyranny of shrimp. If it wasn't already obvious, these are not very realistic LSAT paragraphs. So if we're being asked here, which of the following must be false, pause the recording and take a look at these three answers, and then unpause when you want to hear about them. Welcome back. Is it possible that no one, including Solomon, reads his blog? It is. All we know is that every day he writes another article. We don't know if he reads that article. We don't know if anybody else reads that article. So it is possible that he is just typing these and no one is ever reading them. A could be true. B says that the shrimp he was eating a month ago are heavier than the shrimp he's eating now. Well, that actually is contradicting something we know. There was a comparative relationship there that the number of shrimp has gone down, but the total weight of shrimp has not gone down. If we think about the math involved, your total weight of shrimp is just how many shrimp you ate times the average weight per shrimp. If I eat 10 shrimp, and on average they each weigh about 20 grams, then I ate 200 grams of shrimp. If we find out that he's eating the same total weight, or at least as much, even though the number of shrimp has gone down, then the only way to balance out that math is to infer that the average weight per shrimp has gone up. The possible inference these facts allowed us to make are that for the past 2 weeks, he's been eating, on average, heavier shrimp. B contradicts that idea and says that the shrimp he was eating a month ago are heavier than the shrimp he's eating now. Now, there are slight technicalities with a month ago in the sense that our paragraph never exactly clarified what Solomon is doing a month ago, but we will take this as a 98% provably false type answer. C says that he only writes blog articles about shrimp. Can we infer that? Heavens no. We know he writes blog articles about shrimp, but he might write blog articles about other things as well. I've heard he has a passion for wet naps. So C could be true, could be false. The important thing is it doesn't contradict anything. In order for us to pick C, we would have to be able to tell from this paragraph that he writes blog articles about things other than shrimp. And we haven't heard anything like that, so we have no way to contradict it. So B was our correct answer. It contradicted a mathematical inference we could pull out of that comparison. Again, the two patterns for correct answers are that they will contradict a conditional statement they gave us, or it'll contradict a possible inference we could have made. So when you read a must-be-false paragraph, you should still use your normal inference brain to look for what sort of possible things you could infer by combining two or more ideas. And remember that must be false doesn't mean which answer is making a bad, unsupported inference. Illegal reversals and illegal negations are illegal inferences, but they're not contradictions. It's not about hey, we didn't talk about that, therefore it must be false. Anything out of scope could not possibly be contradicted. You can only contradict something that you know about. But must be false is saying something we do know is wrong. Let's take a look at a real example from Test 71. Pause the recording, try this problem on your own for about 1.5 minutes, and then unpause when you're ready to talk about it. This is a very atypical phrasing for a must be false type of question. It's talking about violating a principle. The word principle almost always means a conditional claim on LSAT. So must be false would have us thinking conditional, and principle would also have us thinking conditional. Sure enough, the word unless is there. Unless is a very common conditional trigger word, and one of the easiest ways to always know you're setting it up correctly is to learn that unless is the same as if not. The if part of a rule goes on the left, and if not is just saying we'll put the negated version of this on the left. The idea that comes after unless is that your purpose is acting in the interest of some other person. Since we are thinking, okay, if not, we're going to say if your purpose is not acting in the interest of another person, then you should not intentionally misrepresent their beliefs. All right, so we have a principle, it's a conditional rule. We used unless, if not, to make sure we set it up correctly. Now we have to think, all right, what does it mean to violate a principle? It means to contradict a conditional. And the form for that is I need a counterexample where the trigger happens, but the outcome doesn't. So we can anticipate an answer that would sound like the left side happens, somebody was not acting in the interest of somebody else, but the outcome is opposite of what it should be. This person does intentionally misrepresent the other person's beliefs. If you want, you can pause the recording one more time to double check your answer to see whether it gives you the blue and the red. Let's look at choice A. If we're wondering whether or not Anne was acting in the interest of Bruce, that last idea says she was definitely not acting in his interest. In fact, she just wanted to make him look ridiculous. Okay, so we've established the trigger. Now we want to see Anne does intentionally misrepresent Bruce's beliefs. She tells someone that Bruce thought that the moon landing was a hoax, even though she knows he doesn't think this. Okay, well, so then, yeah, she definitely intentionally misrepresented Bruce's beliefs. It looks like this is our correct answer, because it triggered the rule, but then gave us the opposite of what the outcome told us we should do. Let's check the other answers to feel better about picking A. B says that Claude told someone Thelma believes in aliens, even though he knew that wasn't the truth, but he wanted to keep this other person from bothering her. So first we wanted to know, is Claude acting or not acting in the interest of Thelma? He is acting in her interest. That last idea is saying he was just trying to keep someone from bothering Thelma. So we don't get off the ground on this one. The other part is right. I mean, he does intentionally misrepresent her beliefs, but because he does so for her sake, it isn't covered by this principle. This principle only covers cases when you aren't acting in the interest of the other person. We can get rid of B. When we scan C, trying to figure out whether or not one person was acting in the interest of another, we can see that the motivation was he wanted these people to think highly of Maria. So it sounds like he's acting in Maria's interest. That means that, again, we're not going to get anywhere with this because we didn't establish that blue, the trigger that says he wasn't acting in their interest and he intentionally misrepresented her beliefs. We also don't really know whether he misrepresented Maria's beliefs. All we know is that Maria didn't want him to say a certain thing, but it may have been a true belief Maria had. So it doesn't match the trigger, but it also doesn't clearly match the outcome as well. When it comes to D, what are the motivations of Harvey? He said what he said because he thought she would like him as a result. All right, so Harvey is saying something not in the interest of somebody else, but in his own selfish interest. He's not acting in the interest of Josephine. Does he intentionally misrepresent Josephine's beliefs? No, he intentionally misrepresents his beliefs. He lies about thinking that she'll one day be famous, but that's not covered by the rule. This rule is saying you shouldn't intentionally misrepresent what other people believe. It doesn't say whether or not we're allowed to intentionally misrepresent our own beliefs. Get rid of D because it doesn't match the outcome. When we look at E and we check on Wanda's motivations, she is just trying to embarrass George. She wants people to know that George is a geography fool. Okay, so we've established the blue. She's not acting in the interest of George. Does she intentionally misrepresent George's beliefs? We know from this paragraph that Wanda knows that Egypt isn't really in Asia, but we don't know whether or not George genuinely believes that. She might be correctly representing George's silly belief that Egypt is in Asia. Since we don't know whether or not George actually believes Egypt is in Asia, we can't tell whether she's misrepresenting his belief or correctly representing it. Thus, this answer does establish the blue trigger, but it's not clearly delivering that red outcome. So A is our correct answer. We were trying to violate a principle. We knew we'd be getting a conditional rule, and we know that violating or contradicting a conditional means that you establish the trigger is happening, but then say the outcome isn't. So we picked an answer where somebody was not acting in the interest of someone else and was just trying to make Bruce look silly. And she did intentionally misrepresent his beliefs. She told people that he thinks the moon landing is a hoax, even though she knows he doesn't actually think that. Conditional logic is the name of the game in Must Be False. The vast majority of these end up testing conditional logic one way or another. Let's take a look at one more example. Pause the recording, give this one a try for about a minute and a half, and then unpause when you're ready to talk about it. Welcome back. This question stem gives us the could be true except wording. When we go to this paragraph, do we see any conditional logic this time? Yes, we actually see quite a bit. Only when, until, essential, if. Yes, those are all conditional logic trigger words. It's about 15 or 20 words we should memorize that show up a lot to introduce conditional logic. And we want to memorize for each word whether it introduces a sufficient condition that we would put on the left side of the arrow, whether it introduces a necessary condition that we would put on the right side of the arrow, or whether it's one of those special if-not words like unless that we saw in the previous problem. The most common sufficient triggers are things like if, when, where, whenever, wherever. Any universal like all, each, any, every. And the only is a sneaky little counterexample, because only and only if and only when are the most common necessary trigger words. You'll also see words that sound like a guarantee. Things that ensure, imply, guarantee, always lead to something else, introduce a right side idea. And words that introduce necessity. If we're saying that we require something, we need it, we depend on it, that thing also would go on the right side, on the necessary side. In fact, it's just really nice to remember that if it's required, it goes on the right. And then we have these three words, unless, until, and without, where the rule that you want to memorize is that you will put whatever idea comes after that word on the left side of the arrow, but a negated version. So if not is saying you treat it like if in that you put it on the left side, but you need to put the negated version. So returning to this paragraph, the first one we saw was only when, which is just like only if. It introduces a right side idea, a necessary condition. So helping students become independent learners has to be on the right side of the arrow. And that means being an effective teacher goes on the left. In our second sentence, we see until, which is an if not. So we need to put on the left side if teachers do not have the power to make decisions in their own classrooms. The tricky thing here is that the other idea needs the not that appeared earlier in the sentence. We're saying if teachers don't have the power to make decisions in their own classroom, then they can not enable their students to make their own decisions. This was a weird phrasing where I could say, until you clean up your room, you cannot have dessert. But I also could have said, not until you clean up your room can you have dessert. They would mean the same thing. The third sentence gives us the word essential, which is a synonym for necessity. So I would ask myself, all right, what's the required thing in this sentence? If you're telling me that students' capability to make their own decisions is essential, it's required, then I know that idea goes on the right side of the arrow. So I need students are capable of making their own decisions on the right side. Becoming an independent learner then takes the left side. We can read conditional statements as the left side requires the right side. So I can read this conditional as becoming an independent learner requires that they're able to make their own decisions. Lastly, the final sentence uses if, the classic, the put it on the left side. So if teachers are effective, then they must have the power to make classroom decisions. One bizarre thing about this question stem is that it said we were going to be reading an argument and still being asked what must be false. So I wasn't sure if we would have to treat assumptions as though they are true. But before I even get there, I just want to figure out what's going on with all this conditional logic. When we get more than one conditional logic rule, they often link together. So we want to look to see, do they have any repeating ideas? Well, effective teachers showed up twice. Becoming an independent learner showed up twice. Having the power to make classroom decisions showed up twice. And being able for students to make their own decisions showed up twice. All right, let's pull out that first rule. If you're an effective teacher, you can help your student become an independent learner. Can we chain anything onto that? Sure, we have a rule that says if the students are becoming independent learners, then they must be able to make their own decisions. Can we chain anything onto that? Well, I see a rule about students making their own decisions, but I would need to contrapose it to chain it on, so I will. I'll think, all right, if students are able to make their own decisions, then the teachers did have power to make classroom decisions. Those first three ideas chained A to B, B to C, C to D. So let's synthesize it and make this look a little bit easier. If you're an effective teacher, you can help your student become an independent learner, which means that student is able to make his or her own decisions, which means that you, the teacher, clearly had the power to make classroom decisions. When we look at our conclusion, we realize there's really not a new thought happening there. That was just a correctly derived conclusion. Effective teacher implies power to make classroom decisions. So I don't have to worry about whether or not there were assumptions that we should also be treating as true, because this argument was actually a valid argument. The conclusion just summarizes our conditional chain. If we're going to find something that must be false, and we have a big old conditional chain, then we should again be reminding ourselves that's going to sound like you are the trigger, but you're not the outcome. But the question stem was actually even more specific. It said, what would we know about teachers who have enabled students to make their own decisions? So that's our third link. And when that is true, it tells us that fourth idea. We know that if the students are able to make their own decisions, these teachers apparently have the power to make classroom decisions. So we can infer these teachers definitely have power to make their own classroom decisions. But we can't go backwards in a conditional chain, so I have no idea whether they're effective. I have no idea whether they are helping their students become independent learners. When we look at the answers, we can see that D is actually giving us that inference. That must be true. They definitely have the power to make decisions. So D is wrong. We're looking for something that must be false, and D must be true. A, B, and C are dealing with those unknowns. We don't have the ability to go backwards, so we have no idea whether or not they're effective. We have no idea whether or not they're helping their students become independent learners. E, meanwhile, contradicts the inference we were able to make. We know they have the power to make decisions in their classroom, so E is contradicting that, saying, no, they don't. They don't have the power. So E is our correct answer. D was something that must be true. That actually was the available inference. A, B, and C were just toss-ups. They could go either way. We have no idea. All right, so once again, how do we spot must be false questions? It might say must be false, might say cannot be true, could be true except, least compatible, or violates a principle. The most common reasoning structure by far will be conditional logic. Most correct answers will either contradict a conditional rule, or they'll contradict some available inference that we could have made by combining ideas. When it comes to trap answers, you could lump them all together and just say, well, they all could be true. But when we think about how the test writers design them, we could get a little bit more granular. Some things are unopposed, meaning they certainly fit within the information we were given. If I say that somebody uses a wet nap after they eat shrimp, it's certainly unopposed to say they also use it before they eat the shrimp. Out of scope is really referring to bringing up brand new things we never talked about. Bringing up a brand new thing means that there's no possible way we could contradict it because we didn't even get any information about it in the first place. Supported is more like an answer that is a valid inference or sounds like it pretty reasonably goes along with the paragraph. We're looking for something that starkly goes against the paragraph. Reversal and negation refer to ideas that are tempting because we know it's an incorrect manipulation of a conditional logic rule. It's not a valid inference, but that's not the same thing as contradicting a rule. Finally, some answers will be too weak to contradict, which is sort of like saying unopposed, that they could still fit within the margins of the facts we were told. If I'm told that most clowns are scary, and an answer says, some clowns are really nice and welcoming, that doesn't contradict, it's too weak. There's room for some clowns to be nice when I've only said most clowns are scary. All right, thanks a lot for learning with us. Please check out any of our other videos on YouTube, or join us on LSATlab.com.